Hello students, so this is Brock Skaggs. I'm going to make this video demonstration of putting together the assembly you see in the image before you inside of SolidWorks. And so instead of having a regular standard drawing here, I'm just going to work off the image there. You can see I've got 4 components total here. 3 of them are all the same component, just 3 different instances of it, even though 1 is green and 2 of them are white. And so I just did that to make sure you can tell that there's 3 distinct pieces in that portion of the assembly. Other things you can see I've shown the front planes of those. That way we can talk about some of the mate types. And so you can see I've got like an angle mate there from the first to second instance. I've got a perpendicular mate there for the second to third. And then I also have a tangent mate between this peg feature and the third instance of this kind of pipe fitting looking component there. I've also went in and shown the coordinate system. There you can see a user-defined coordinate system. It's going to be on the very bottom face there, and then right at the center of that cylindrical portion of the first instance of the little pipe fitting component there. And so that is the goal. As usual, we'll check with mass properties at the end to make sure we've arrived at the correct destination. And so with that being said, let's go ahead and hop right into SolidWorks. And so I'll just go ahead and create a new assembly. I'll go ahead and hit escape there, check units as IPS, should be fine. Here there's no dimensional unit there as far as I'm not on a distance mate or anything, so it shouldn't matter a whole lot. And so I'll just go over to insert components, I'll browse, and there is the elbow part that I'm looking for. And so plopping it in here and just checking, yeah, that appears to be roughly correct. And so, as usually, it has fixed the first component, so our first step will be to right-click and float it. That way I can be sure I place the center mass of the origin of the assembly in the correct location. And so here, there's the origin here, here's the origin for this part. I believe that is the exact same spot as where I want to place it on the assembly, as if I check in the image there. So what I'm going to do is just hold control. I'll select both the origins, one origin being the assembly origin, the other origin being the origin of this elbow component, and I'll just go straight into mate. There we go. And so the first thing it does is it makes those 2 points coincident, and there's also a checkbox here that says align axes here. I believe that will be what we want to do, and so here we're aligning the x-axis of the part to the x-axis of the assembly, y to y, z to z, and so forth there. And so that looks good, and that should fully constrain that part in space. And so we are in good shape. So the green one is a second instance of this part, and so what I'll do is hold control down and drag off to create the second instance. That just keeps you from having to go to insert components again. Here, this one was a little bit different, and so what I'll do is go ahead and get into render tools here and just make that one green so it's similar to the image. It's a little too dark. There we go. And so there I applied the green appearance to the component part level, and so now I've got a green version of the same thing. So the same exact part here, just went and think of it as spray painted to green, I guess. And so now we're ready to start applying mates to it. And so as usual, I usually like to get into rotate and move. That way I can kind of get it in the correct orientation to help SolidWorks out here. And so that looks pretty close to correct. You can see that little hole there. And so now we know that these 2 faces here are going to be concentric. And so I've got both those cylindrical faces selected, go into mate, and it automatically goes to concentric for me. So if I kind of slide it out here, I believe this thing sits right inside. You can kind of see that surface right here. And so I'll have that one selected, and then I'll select the corresponding surface on this elbow. So that thing slides in there and gets seated correctly. And at this point we have this rotation that we have to deal with. And so for the rotation, that in the drawing we have as 120 degrees, and so that's between front planes of the individual components. And so if I show the front plane here, it already is shown, and looking here, the front plane is shown here, and so it's just left to go to view planes in order to actually see those planes in space there. And so you can see them right there. And so we need to apply a mate between those, and so I'll go mate, select this front plane, select this plane. By default it goes to make them coincident, which is not what we want. We want an angle in here, and so reverts back to close to where I had it, and so this is where putting it in a configuration that's close to the desired one helps you out here. And so here it was at 116.26 roughly. We just need to adjust that value slightly to 120 degrees there. And so that's the angle between those two planes, and that allows us to arrive at a nice fully constrained set of components here. I'm going to go ahead and go view and hide this sketch. That sketch is what you're seeing right here, but I'll keep the planes on for now. So next we need another instance of the elbow. So again, hold control down and drag off in order to create that. And then to start off, you can see it's very similar mates to begin with. And so here we'll use concentric in order to get us started, and then we can pull this thing out and go apply the mates to get it seated. So coincidence between those two faces. And then we're back at the same problem here. We still have the rotational aspect of this assembly. And so what we'll do is use perpendicular here in order to fix that problem for us. And so here the planes we'd be learning about is the front plane here of the second instance of the elbow and the front plane of the third instance of the elbow. And so it should be just a matter of going into mates, selecting those two planes. Again, it tries to rotate them to coincident. By default, that's not what we want, so we just pull over here. Here is perpendicular from the quick access box, and that gets us the desired result there. And so just checking to make sure everything is fully constrained, and everything does look good at this point. Finally, we've got the little peg piece to move in here, so I'll just go browse to it since we haven't got an instance of it in here yet. And so there's the peg, and just plop it into space. And so easy enough, this thing's going to have to be concentric with that hole. And so we'll just go to mate, select this face and this face to make it concentric. And so we've got the rotation as well as the translation left to deal with. On the translation side, it looks like it becomes tangent to this cylindrical face. So this planar face here and the cylindrical face, I already had mate going, and so as soon as I selected both of those, it wants me to apply the tangent mate, which is appropriate for this. And so now we should just have this rotation, as you can see. So the rotation inside of the drawing, there's nothing really showing an angle there, and it looks pretty close to parallel. So this is one you would be assuming that yes, they want a parallel mate between this face and the end face of my elbow there. Again, if it wasn't parallel, it would be on the creator of this image or the creator of the drawing's responsibility to say, hey, this isn't parallel, but it's 5 degrees, 10 degrees, whatever that small angle is. And so, since I'm not seeing that, I'm making the assumption that these two faces need to become parallel to each other. And so that's the default one for SolidWorks to go to in this situation, which is great. And I can just accept that. And so now if I turn off the planes, you can see we've arrived at the finished part here. And so you can kind of compare it side by side here with the image, and you can see we're in pretty good shape here. And so that's one thing, if you're taking, say, the CSWA exam, you do have a finished part there. It's best if you could get it in dual monitors. That makes taking those exams fairly easy. That way you can devote an entire screen to the SolidWorks environment, and then you have on your second screen the tester program, if you will, with all the prompts it has there, so you can just glance back and forth and make sure you're going in the correct direction there, as opposed to having to go the Alt-Tab bit here as far as toggling between different applications there. But if you only have one monitor, it is more than doable there as well. Just a little bit slower, if you will, as opposed to just glancing back and forth. I think we're in the right spot here, so let's go ahead and go to evaluate mass properties just to check. 0.37 is the mass in pounds, 2.59 for the x coordinate, 4.61 for the y, and negative 1.68 for the z component of the center of mass there. And you can see its relationship right here, or its relationship with the rest of the bodies by this little triad right here. And so that should conclude this video. Uh, Thank you for watching. It looks like some of the things we looked at were tangency mates and perpendicular parallel mates, as well as the angle mate as well. And so again, thank you for watching the video, and I hope it helps you in developing your SolidWorks assembly modeling skills.